Okay. Hey, this shout goes out to my third-hour class, who's so awesome. You want to say hi?
No.
Okay, here we go. So what we're going to do is we're going to talk about the rock cycle. I realize we may have covered a little bit of this. We're going to go back over it just a little bit, just kind of bring ourselves back up to speed. The rock cycle, what are you going to be able to do? You're going to say, by the time you're done, you're going to say, I will be able to identify 3 major rock types. We're going to cover those today. We're going to go over those today. We'll get those done. The next, we're also going to explain, you're going to be able to explain how they got formed. From there, you're going to be able to summarize the steps of the rock cycle. You're going to say, I can summarize these steps in the rock cycle. So yesterday or the day before, we talked a little bit about igneous rock and different rock that's out there. And igneous rock, the word rock means, igneous rock means to come from fire. And so basically, when we're talking about that, we're talking about rock that's coming from magma. Again, magma, when it reaches the surface, it cools down. When it cools down, it becomes lava. That's the moment that magma becomes lava. Now, here's the thing. We have examples all over our planet of igneous rock. But it's not exactly where you think. First place you think is you're going, I'm thinking Hawaii, right? Good example, right? Why? Because they're volcanic islands. Another one, I'm thinking Pompeii. We saw a video on Pompeii where basically the town was inundated by volcanic ash, volcanic pyroclastic flow, and everybody died. Tragic. It was unfortunate, but it's a cool time capsule. So we get to see exactly what time was like. But we have igneous rock in places like Colorado, in places like Yellowstone. And the thing is this rock is an indication that Colorado and Yellowstone and all these areas were once the formations of supervolcanoes, right? And so it's a giant supervolcano that's kind of sitting there waiting. But it's pretty cool. All right. The next thing that we're going to talk about is sedimentary rock. Again, sedimentary rock from sediment. Let me pull out a couple of pieces of sedimentary rock here. So what you can't see on the video is you can't see that I've just pulled out a handful of pebbles, and I've also pulled out some rocks. And in the rocks, to describe them to you, what would you describe these as, Brandon? What do you describe that as?
Pebble.
So there's pebbles in the rock. Can you pull one of the pebbles off there? No, you can't pull it off there. So what's happened is these pebbles broke up for whatever reason, whether it be wind, water, wave, whatever, broke up, landed in a position, usually flat on the bottom, and they were cemented together by something. Don't know yet what it was, but something is holding this together because Brandon just said he can't pull it off. He can't break it apart. Because of that, it is sedimentary rock. Okay? So sedimentary rock, here you guys can pass that around. There you go, pass that around. You can see bits and pieces of chunk. And again, it's rock that have been broken off. And here, I'll take that from you. Rock that have been broken off and again, cemented together in a form. All right, the next one we're going to talk about is metamorphic. So you'll see. Okay. So the next one, or the third one, or the last one, we refer to as metamorphic. Okay? Metamorphic. I love watching the movie A Bug's Life. Anybody ever see the movie A Bug's Life? Yes. Right? So everybody's seen the movie A Bug's Life because it's the world's greatest movie. Right? So should have won an Academy Award. I'm not sure it didn't, but it should have. In the movie A Bug's Life, You guys remember Manny? What was Manny?
He was a man, I think.
He was a praying mantis
That caterpillar.
in a bug's life.
Oh, that's Ice Age.
Yeah, not Ice Age. You got that a little bit backwards. That's okay. Mammoth versus praying mantis. Different story. That's okay. He was performing a ritual on Heimlich. Anybody remember what that was?
No.
What was Heimlich wanting to be?
I don't know who that is.
He wanted to be, I want to be a little butterfly. You remember that? You guys remember that? Sure you do.
Oh, they kept
Right?
there's
So,
many.
what was going on with Manny is Manny was going to perform the ritual to change Heimlich into a butterfly. So he goes into the Szechuan carton and I call on the ancient Szechuanian spirits to change a metamorphosis. What does the word metamorphosis mean? To change. Yes, very good. So when we talk about metamorphic rock, it is a metamorphosis, or it's metamorphosing. It's changing. Okay? So I've pulled out some metamorphic rocks here. Here's one. Please, 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 please don't drop this. It's been dropped once before by a student. It was an accident. Feel bad. I fixed it. This was given to me by my grandfather. This is a piece of petrified wood. Right? It's a beautiful piece of petrified wood. You can still see the bark on the outside, and you can still see the grain on the inside. Now, what you have here is a piece of wood that the minerals were removed. The parts of it were exchanged with minerals. So water with minerals came in, exchanged. It changed under heat and pressure, and we have a piece of wood that was changed into a rock. It metamorphosed. Back by Alexis, there is a tombstone, right? That tombstone was a piece of limestone. In other words, the ancient creatures on that piece of sedimentary rock right there that Brandon just tried to pick off, they are the basis of limestone. They're coral and other diatoms that are in the ocean. Over years and years and years of heat and pressure, they changed. They changed to harden. And so what do we have? A marble tombstone now. And so it metamorphosed. Okay? Real simply. So the rock cycles. If we look at the rock cycle, and the rock cycle's awesome, right? Anytime you say the word cycle, you're going from place to place to place to place, and it's coming back, right? And so what we know is that there is no starting point or stopping point. It's like, which rock is the beginning for the rock cycle? There isn't. Because what happens if you take a piece of sedimentary rock and chuck it into a volcano? It melts. Pretty stinking hot, right? So once we started with igneous rock, how did we get igneous rock? You guys remember when we talked about meteorite impact hypothesis? Okay. Just real quickly, when do you think igneous rock started?
Probably about the same time as planet formed.
So we were slammed into a bunch of, even a planet size turns molten. We have liquefied rock. We go back about 4.6 billion years ago. Whammo, here we are, right? And so now all of a sudden we see the igneous rock. It breaks apart from wind, water, waves, whatever, and it makes sedimentary rock. Then it, under heat and pressure, metamorphosed, changed into metamorphosis. Now, figure 10.3 in your book is a good example. This is what it looks like. This is what it looks like. Now, you'll note that there's no starting point and stopping point for this. In fact, there's a bunch of freaking arrows in there that go all sorts of directions. Lucas, why are they going all directions?
Because every kind of rock can go into different kinds of rock.
Every kind of rock can be made into every kind of rock, right? And so there's no beginning or ending to this thing. And so it's like the song this is the song that never ends. You've heard that song, right? This is the same thing. You can go on and on and on forever. So whether it be from melting, magma, or crystallizing, metamorphic rock, or weathering, compaction, cementation, we have the ability to change any kind of rock into any kind of rock. Which brings me to this. Now, I know how much you guys enjoy doing cool things, right? So, Miss Bristow, here's what I decided to do. I wrote a song. I know, it's hard to believe. Brandon writes, I was going, dude, you didn't write no song. I did. And it's a good song. And this is it right here. This is exciting. So what I thought I would do is I would play my song for you. What do you think? All right? Yeah. Okay, hold on. Here, hold this. Don't say any bad words in there. All right, here we go. Got it tuned up now. I'd like to take this moment to say thank you to all the people who helped make this a success for me. The tour's been good. I enjoyed it.
Yeah.
Being on the road is kind of tough sometimes, but I miss my loved ones. Wrote a couple songs about it. But I wrote this song called the Rock Cycle Song because I was thinking about home and how much being on the road makes me think of rocks. Right? You can't laugh into the microphone, son. I got to be able to play here. So, I'm going to have to turn around. I apologize because I forget the lyrics sometimes, but hold on. So it goes like this. Sedimentary rock has been formed in layers, with often found near water source with fossils as decayers. Pretty good. Give me a round of applause there. Thank you. Got it all tuned up here. Yeah. Here we go. Round 2. Then there's Igneous Rock, here since Earth was born. Molten lava, cooled and hard. That's how it was formed. Almost messed up there, but I got it back there. All right, here we go. And the last one. These 2 types of rocks can also be transformed. With pressure, heat, and chemicals, metamorphic they become. All right, here you go. Give me a round of applause. Now, Miss Bristow, a performance like this would not be any sort of a performance unless we had the audience join in with the song. Here we go. Yeah. Here we go.
Okay,
now, just so you know, I'm not into blackmail or anything like that. But I will say that right now, if you don't sing and I'm watching, you're probably not going to pass my class. Or furthermore, you'll probably not pass any of the classes at the high school because I've got a little program in the grade book that'll cause everybody's grades to wipe out. So you must sing or major disaster happens for everybody at the school. Here we go. Anybody like? Here we go. We'll start. It's in the key of A. Here we go. There you go. Turn it up. There you go. Here we go. Again, if you're not singing, you're failing. Here we go. 1, 2, ready, go. Sedimentary rock has been formed. Okay, you're not singing.
Oh my God.
You're not singing. Let's try this one more time from the top. There's the key of A. There you go. 1, 2, ready, go. Sedimentary rock has been formed. You're still not singing. Okay. You know what, Miss Bristow? I just got a great idea. Since they don't want to sing, why don't we have them write their own song?
Oh man. Oh, this ain't.
And then,
Singing is a lot easier.
I'd rather have a song.
and then, Lucas,
You know what? I will sing it myself if no one else has to sing it.
you gonna come up and sing with me?
Yeah,
Lucas,
I'll
come
do
on
it.
up. Give him a round of applause.
Yeah.
Here we go. Here we go. Ready? Here we go. Ready, Lucas? 1, 2, ready, go. Sedimentary rock has been formed in layers, often found near water sources with fossils as decayers. Good job. Here we go. Round 2. Then there's Igneous Rock, here since Earth was born. Molten lava, cool and hardened, that's how it was formed. Good, last one. These two types of rocks can also be transformed. With pressure, heat, and chemicals, metamorphic they become. Yeah! Round of applause! Now, here's the thing. Look, here's the thing. I have fun with that song, but if you think about it, the words really make sense, right? Because if we talk about sedimentary rock, it's bits and pieces of stuff, right? They're all cemented together. Where are they found? Near water. Why? Water breaks things down. It also cements things together, right? Igneous rock. Here since Earth was born. We just talked about that, Travis, right? Molten lava. So now all of a sudden, molten lava cools and hardens. It's got igneous rock. Third part, they all get transformed. The ancient Szechuan spirits of metamorphosis. It changes. That's what's stinking cool, man. That's the rock cycle. And you know what? Each and every one of you can do this. You can talk about and lay out the rock cycle because it's not that hard. Okay? I want to play this little video clip on the rock cycle. All right. I apologize. It was up here 2 minutes ago. No, it's okay. No big deal. No big deal. All right. Here we go. Rock cycle.
You know, Globey, here on Earth we have three basic types of rocks: igneous, sedimentary, and metamorphic rocks. Scientists classify these rocks by the way they were made. Igneous rocks are formed when lava from a volcano cools and hardens. Igneous rocks are also formed when magma cools below Earth's surface. Sedimentary rocks are formed when the elements wear rocks down into tiny particles of dust, sand, and soil. Wind and water help move these particles around and deposit them into layers. As time passes, these layers are cemented together and harden into new rocks. Metamorphic rocks form when sedimentary or igneous rocks change after being exposed to extreme heat or pressure without melting. As conditions on Earth change, rocks may change from one type to another. Sedimentary rocks can change into metamorphic rocks, or, if they melt, into igneous rocks. Igneous rocks can change into sedimentary or metamorphic rocks, and metamorphic rocks can change into sedimentary or igneous rocks. Scientists call these changes the rock cycle. But NASA scientists want to study rocks from other places, like the Moon and Mars as well. They want to see if other rocks are like the rocks found here on Earth. By studying rocks from the Moon or Mars, scientists can learn a lot about how the land was formed and how it has changed over time. The history of rocks. They can tell how the geologic history of another planet compares to the geologic history of Earth. During the Apollo missions to the Moon 40 years ago, astronauts brought back dozens of rock samples from the Moon's surface. Today, scientists from all over the world have a chance to study these lunar rocks. And by studying the rocks, scientists have discovered that the rocks on the Moon can be classified into three basic types too. The first is lunar basalt. This type of moon rock is similar to volcanic lava found on Earth. It starts on the Moon in a lava state and then cools to form a hard rock. The second type of moon rock is called a northocite, which forms from the cooling of a large ocean of magma shortly after the Moon was formed. Lunar breccia is the third type of rock. Light areas of the breccias are either pieces of a northocite or unmelted rock. The dark areas are either basalt or melted rock from the meteoroids hitting the surface. Thanks to the lunar samples brought back by NASA astronauts, scientists finally know what the Moon is made of. No, Globey, it's not cheese. But scientists aren't the only ones who get to view the lunar samples. The Lunar Sample Laboratory Facility at NASA's Johnson Space Center also lends moon rocks out to educators and museums around the world. Some of the samples have been preserved in round discs of clear lucite. People who have had special training take those samples to classrooms and museums so many other people can see what these special lunar rocks look like. A few museums have their own moon rock on display, so you can visit a museum and see a real moon rock in person. The lunar rock samples brought back from the moon 40 years ago still provide meaningful data to scientists all over the world. They continue to teach us how the rock cycle on the moon is similar in many ways to how rocks change on Earth, or even other planets. So now you know how rocks grow and change beneath our feet, thanks to the rock cycle.
So, when you look at the rock cycle, it's easy to understand that we're going back and forth with the various material. Now, there's no beginning, no ending. What we're going to do is we're going to get started here, and actually what we'll do is we'll call it a day on this series of notes, and we'll be done with that. And with that, we're going to get started here, if I can pull this up. Okay. And thanks for listening.